in the second unit, this portion, RL, RC circuits, this portion, circuit analysis, RL and RC circuits, okay. Now coming to RL circuit, it will be like this, only R and L components connected, only R and L, this is started with RC. So here RL, you can see RL. You know, in the mathematics complementary function particular integral, okay, which is otherwise called as natural response, forced response. You have tried KVL. When switch is closed, you have tried KVL. This will become the KVL. And when we derive equation, when we derive substituting the initial conditions, when we derive equation, this is the current equation. Current is an increasing factor in the RL circuit. Okay, you have to remember V by R 1 minus e power minus t by tau, increasing factor. So when current is increasing, output is taken across L, inductor. In the RL circuit, output is taken across inductor. You see here, L is present at the end. Okay, so output is taken across inductor. And VR, voltage. Okay, the current and VR looks similar. Current in the graph, you can see current and VR will look similar. Both are increasing. Both are increasing graph. Okay, and the VL value will decrease. VL, it will be a decreasing graph. This is about the RL circuit. In RC circuit, this is RNC. You can see here, this is RNC. Take the initial conditions, okay, initial conditions, and then write the KVL equation. This is the KVL equation, and substitute all the initial conditions. You will get current equation, a decreasing graph. V by R into e power minus t by RC. RL circuit means current increasing, RC circuit means current is decreasing. Okay, and time constant you have L by R in the RL circuit, RC circuit R into C is the time constant. Okay, and the graph you see current is decreasing graph. Current is decreasing graph. VR also decreasing graph. Current and VR will look similar. Okay, VC is an increasing graph. VC is an increasing graph. So what I have discussed so far, I will just write into this PPT, so it will be easy for you. What you have to remember, background derivation I am not going with now. Background derivation directly I will write whichever required to remember. Okay, whichever required to remember, I will just write down. This is RL circuit. This is RL circuit. Okay, R and L value will be there. Supply voltage V, supply voltage V, R, L. So current I is present. So current is an increasing graph, I told you. Current is an increasing graph. Current means V by R compulsory, no? So 1 minus e power minus t by tau. Okay, this is first equation you will remember. Next, VR. VR also will look similar. V by R, V only will come. By R will not come because it is a voltage parameter. V is nothing but supply voltage. V is nothing but supply voltage in the diagram. Okay, V is nothing but supply voltage in the diagram. V into 1 minus e power minus t by tau. This is second equation you will remember. And output is taken across inductor. No, this first equation 1 and 2, they are increasing graph. So now this is a decreasing graph. V into e power minus t by tau. Okay. Once you see in the question paper RL circuit, you write the circuit, these three equations, you will get 2 marks definitely. Okay, you do or don't do any other things. If you see RL circuit, you draw this circuit, write the three equations definitely. Like this, you have to gather 2 marks here and there. You have to gather and just get it cleared. Okay, and now when you draw the graph for it, this is the, if we take, this is the reference. Okay, this is the reference. And current is an increasing graph, I told you. Current is an increasing graph, I told you. This is I, current increasing graph. This graph also, you just draw it. Okay, you just draw the graph also. Then VR also increasing graph, I told you. VR also increasing graph. And VL is decreasing graph. VL is decreasing graph. If you have some colors also in the exam paper, except red color, other things you can use. Don't use red color in the answer paper. Okay, and this is VL. VL is decreasing graph. These are the graphs. And now if you see this constant value is V by R. Constant value is V by R. Okay, current reaches this maximum. And here the tau is time constant, tau is time constant, tau value is L by R. These are the details in RL circuit. You have to by heart these formulas. By heart these formulas. Whenever you see RL circuit, write this much things, you will definitely get 3 marks. Okay. Next, right side I am going with RC circuit. Right side I am going with RC circuit. RC circuit, what you will do? One supply voltage is there, R and C values. R and C values are there. R and C values are there, supply voltage, R, C. Now current is a decreasing graph, we told. So V by R into e power minus t by tau. Okay, this is equation 1. In RC circuit, this is equation 1. VR also looks similar, voltage across resistor also looks similar, decreasing graph. V into e power minus t by tau. This is second equation on the right side. And third equation, capacitor, across capacitor. First two are decreasing graphs, so now it is increasing graph. V into 1 minus e power minus t by tau. Okay, this is third equation. This is third equation. Now draw the graphs. Current graph is decreasing. Current graph is decreasing. You draw the decreasing graph. This is current graph. Okay, and this constant where it starts. This is V by R. Okay. This is yes, please mute. Now coming to I completed. Next VR. VR is also decreasing. Sir, who is that? Please mute mic. Now VR. Okay. We are also decreasing. We are also decreasing graph. Yes, we are also decreasing graph. Next, VC. VC is an increasing graph. VC is an increasing graph. VC is an increasing graph. This is VC. Okay. Whatever other things you do or not, whenever you see the RC circuit, whenever you see the RC circuit, draw at least this. You will get 3 marks.
Ma'am, can you please mute them?
కావాలని చేసినప్పుడు ఇంకేం చేస్తాం? Already many times I told it is common sense. Now coming to this graph. Okay, this graph, this equations minimum if you write this graph, this equations minimum if you write, you will get 3 marks definitely. Now coming to RC circuit, time constant. Okay, RC circuit time constant, it is R into C. Using these formulas only if problems are given, you can also do problems. This topic almost 30% in the second unit. This slide is almost 30% in the second unit. Okay, you can write RL circuit details, problems are given, 1 to 3 equations, you can use it directly, substitute, simplify. RC circuit given, write the graph, equation, circuit, and problem given, you can substitute, simplify in the formulas. Okay, that is what I have kept this one problems. RC circuit, you can see here, these are derivations. Final equation will come as we discussed. Now coming to RL circuit, this is a problem. RL circuit, this is a problem. You can say R value given, L value given, supply voltage given. They are asking to find I current, VR and VL. Okay, directly equation 1, 2, 3, you substitute, simplify, that's all. You need not follow this lengthy procedure, substitute and simplify, that's all. I will copy paste the question and I will tell you solve. Okay, solve using the equation, substitute, simplify only. This is RC circuit. No, we have one problem in RC circuit also. RC circuit also one problem is there. They have given R value, C value, okay, and supply voltage value. They are asking current, VR and VC. Direct equation 1, 2, 3, substitute, simplify. This background derivation and all you need not use. You need here they have substituted only. Okay, they have substituted only. This is about the RL RC circuit. Transients I didn't touch. Presently, transient I didn't touch. Okay, and this zero state response, zero input response are the other names for complementary function and particular integral only. Okay, zero input response, zero state response, based on the initial conditions. Based on the initial conditions, what we are substituting, to get the equations 1, 2, 3, those only this 0 input and 0 state response. Okay. Now coming to pole 0 plots. Pole 0 plots, just I will show you what is pole 0 plots. If transfer function is given, you can see numerator equated to 0, you will get the values of s. S is nothing but -1 and -5. So at -1 you will put 2 times. Zeros means you have to put circle. Denominator will give poles. Poles means you have to put cross mark. Okay. So at -1, 2 times circle. -5 also 1 time circle is there. Denominator you equate it to 0, s value will come, s equal to -2. Then here s value equal to -3 minus 2j and -3 plus 2j. Okay, this is -3 real part plus 2j is imaginary part. This is downward, -3 real part minus 2j is imaginary part. Okay, these two are complex poles, and at -2 one pole is also mentioned. -2 one pole is also mentioned. These dots are not part of the pole 0 diagram. These dots are not required. Okay, only cross mark and circle. This is the pole 0 diagram. With this at least 30 to 35% in the second unit, the question whatever comes from the second unit. DC transients also I will teach very easily in the next time when we sit for the discussion. Now I have completed RLRC circuit and pole 0 diagram. 0 input 0 state response is nothing but the same, that output equation what we are getting, that only. If possible I will also put one or two problem in the PPT for this 0 input response, 0 state response. Okay, this is about the some portion in the second unit. Next, easy ones I will discuss first. Okay, fourth unit first half, second half both are easy. Fifth unit also, first half is very easy. Second half of Foster form little bit you have to remember. Square form is very easy. Okay, so we will take a fourth unit now. We will take